Guess who? Yep, it's me again. Okay, so notice I have a title. I have my labels for both axes. I've scaled appropriately, counting by twos again, even though I didn't label every single line. It is in fact by twos. And I put my notch in the graph to show I skipped some values. And then this indicates that I'm counting by 0.5s. And then I also made sure that I labeled the tops of all of the bars. Apologize that they look like a third grader. I know it helps to use a ruler, but you can't do that on the iPad. Now, the question I want to ask you is, compare this to your frequency graph that's directly above this graph. And I want to know what you notice about their shapes. Because you should notice that their shapes are identical. The only difference is that this scale has been turned into percentages. Realistically, you could superimpose this graph on top of the one above it. And that will happen every single time, or should happen every single time. Okay, moving on to the cumulative relative. So notice all my components again have a title. I have the labels on the axes. Oh, this one should have percent. Forgot that. I've scaled by tens. Again, didn't label every single one, but I have counted by tens. And here I put the notch to show that I skipped. I'm counting by 0.5s. And every bar has just its own number, so this is just the 5s. This one is just the 5.5s. This one is just the 6s, and that's why the numbers show up in the middle instead of to the left, on the left side of the bar. And then last but not least, of course, I've labeled all of my bars with the values from the table above. So, as long as you're doing all of those pieces, you are doing correct histograms. Next, box plots. Okay, so some things that you already know because we've been discussing them about your box plot and modified box plot is that the median, in order to find it, you put the data in order from least to greatest and take the middle if there's an odd number of data values. And if there's an even number of data values, you have to average the middle two. The Q1, you cover up the median in the top half and take the middle of that bottom half, and that's your Q1. And for Q3, you cover up the median and the lower half, and then you find the center of the top. In order to find the IQR, which is called inner quartile range, you might notice that I use the letters. All I simply do is take Q3 minus Q1. So it's a range, but it's a range of the inner quartile, so between the quartiles. And you probably remember that range is the max minus the min. We probably should write that down somewhere, that range equals max minus min. And outliers, of course, will stand out from your data and they'll leave gaps. But in order to calculate them for sure, we have to find this IQR. We multiply it by 1.5. And then we use two cutoffs. We have a high cutoff and a low cutoff. So the low cutoff is what happens when I take Q1 and I subtract that product. And if there's anything lower than that, it's an outlier. And the high cutoff is what I get if I take Q3 and add that product. And if I find a number above that, then that's definitely an outlier. And so of course you remember up here in your box plot, so I've got the min, which is the left whisker. This first side of the box is my Q1. The center is my median, or the line that's inside the box is the median. And then the right side of the box is Q3, and then over here is the max. And I'm going to erase all this and draw a modified box plot as well. Okay, so keep in mind that this is still the max, and this lowest point is still the min, but that these dots are outliers, and so these values are just the next value in the data set that's not an outlier on both ends. Okay, see you in the next video.